Hi, my name is Boldy and today I'll be showing you how to build a Bluetooth-controlled Arduino smartwatch. So this smartwatch connects via Bluetooth to your phone, and I've written a small application that runs on my phone and transmits important data such as the time and date and also the battery percentage to the smartwatch. Now you might see some strobing effects on the display. That's just the shutter speed. In real life, you can see the display very clearly. Now my phone also detects when it receives, for example, a WhatsApp message or an email or a phone call, and I can demonstrate that right now. So I'm going to send myself a WhatsApp message, and you can see the application catches that and transmits that to the smartwatch. The smartwatch prints a W on the display because I've received a WhatsApp message, and I'm not sure if you heard, but the vibration motor here on the bottom also started vibrating. So here's a list of hardware components I used to build the smartwatch. Links are in the description below. So now let me point out the hardware components on the device itself. Here, of course, we have an LCD display. I've left a link in the description below. Everything is being powered by this Arduino Nano, and I'll show you the code running on this board in a minute. Down here I have a HC05 Bluetooth module. This establishes the Bluetooth connection to the device. The vibration motor I salvaged from one of my broken phones, Nexus 5. Everything is being powered by this 3.7 volt battery from a drone actually, and all of this sits on this white breadboard underneath. This is the circuit diagram for the smartwatch. It shows how each component is connected to the Arduino Nano. First, the LCD display is connected to ground and 3.3 volt to your board so that it can be supplied with power. Then it uses the A4 and the A5 pins as its input and output for drawing characters and numbers on the LCD display. The battery powers the board and all of the peripherals by connecting to ground and to the 5 volt pin on your board. The Bluetooth module only uses these 4 pins. It also connects to ground and 5 volt, and it uses the transmit and receive pins of your board respectively. The vibration motor is hooked up very simply to ground and to the D7 pin on your board. You digitally write D7 to have this vibrate, and you digitally write low to have it not vibrate. And that's all. This next section, I'm going to walk you through the code that allows the smartwatch to operate, starting with the Arduino Sketch that runs on the Arduino Nano. So the first thing you want to do is include these 2 libraries into your Sketch. You can do that very easily by going onto Sketch and include libraries, manage libraries. You're going to want to download the Adafruit libraries. These specify how your board communicates with the LCD display. So you can simply type in Adafruit SSD 1306, and you're going to have to install this one and the GFX as well. After that, you can find example sketches down in examples, Adafruit, and my board uses the I2C, and it's a 128 times 64 pixel variant. So you want to click that and you can start off there like I did. Next, I have a bunch of variables defined, and these variables sort of grab the information that is transmitted from my phone, and they also do other things. For example, here I have some variables that have to do with storing the time and keeping track of time on the board. So here in the setup function, I have some functions that just set up a cursor, and they also print the words pair Bluetooth on the LCD display because at this stage we don't have a connection. And it also sets up the vibration motor as an output pin. These functions are all provided by the Adafruit library, and they're really useful for displaying characters and numbers on your LCD display. The loop function is more complex. In this first bit, I just have a function that is called every 10 seconds. This part of the code deals with activating the vibration motor at the correct times and for the correct intervals. This part fires when the Bluetooth connection is established to the phone, and it basically captures information that is broadcast via Bluetooth. These next functions, this one counts time upwards on the LCD display. This one displays the battery level and whether or not one has received, for example, a WhatsApp message, an email, or a phone call. So that's all done here. And this last function, it just captures the timestamp that is sent from the phone, because the phone captures what time it is and the date, and that is transmitted over to the board, and then the board itself counts up the seconds and updates the LCD display. Link for this code is in the description below if you want to check it out. Next, I'm going to walk you through the Android Studio application that I have running on my phone and that transmits data to the smartwatch. I'm going to start off with the Android manifest file. Here you just have to define some user permissions. So access to Bluetooth, of course, is very important. And this wake lock and disable keyguard allow you to run the application while the device is locked, which is important when you receive a message when the device is locked. It should still be displayed by the smartwatch. And you must also add this notifier service and this receiver for the phone state. These do similar things and implement these user permissions. So that's the Android manifest. The second activity is what really sends out the Bluetooth commands to the smartwatch. Out of all these variables here, this one is the important one, for this is the MAC address of your Bluetooth module. You can find this out by discovering it on the Bluetooth page of your phone. And yeah, you have to input your unique MAC address for it to work. Down here we have some permission granted for the Bluetooth and some checks on that. Here in this function, I am picking up the time and the date, and I'm sending that over Bluetooth. You load what you want to send into this string called command, and then you call send command. The code for that is further down in this Java file. In this repetitive commands function, I have a handler that basically loops through this code every second. And what it does is basically checks whether or not the battery state has changed or whether or not a new WhatsApp or email has arrived. And if that state has changed, then it should send that to the smartwatch using these commands. Yeah, and that's that. Here in the send command, this I got off another project, so it's basically boilerplate code for me, and it must be inputted so that your application can actually send Bluetooth messages. The next Java file, the notifier file, is more complex. It has to extend accessibility service, which basically gives it the ability to read package names of the notifications. And you're looking for these package names, which is of course WhatsApp, Viber, and this is Gmail. And when that state is changed, this code sends a message to the past notifier values.java file, and that basically ensures that the values or the changed values are sent back to the second activity and are transmitted to the smartwatch. So that's what the notifier class does. To actually check whether or not one is receiving a phone call, you need something called an intercept call class, which extends a broadcast receiver, and this basically gives it the ability to check whether or not there is an incoming phone call. And when that is the case, it uses again the past notifier values. It's just a static class that passes these values to the second activity that again, this is transmitting. I also have the XML file here for what you saw in the demo. This basically just implements a button that says connect Bluetooth, and when you tap it, it establishes the Bluetooth connection to the specified MAC address that I showed you earlier. And that's all really, that's the entire app with plenty of Java classes. I hope you enjoyed this tutorial and you were able to follow. If you have any questions, leave them in the comment section below.